Thank you for joining us this morning. My name is Josh Joyner. I'm product manager of the ArcGIS GeoEvent Server, joined today by my colleague RJ Sunderman, who's a product engineer on the Real-Time and Big Data GIS team alongside myself. We're going to be presenting today on Real-Time and Big Data GIS best practices. So this is going to cover multiple topics, covering GeoEvent Server, spatiotemporal big data store, and some of the different interactions with the rest of the ArcGIS Enterprise stack. This is a more kind of advanced, maybe intermediate advanced session going over that does touch on GeoEvent Server. We don't go heavy into its usage, but I will just very briefly kind of cover an overview of that product's capabilities, since most of what we're going to be presenting today is focused around this product. So the ArcGIS GeoEvent Server provides 5 key capabilities. The first is ingestion, being able to consume data, high volume, high velocity data from connected devices, sensors, kind of the larger Internet of Things landscape. It provides the ability to refine, enrich that data, provide streaming analytics on it while the data's in transit. We provide a data storage solution, specifically through the spatiotemporal big data store. So as you have data coming in, as you're doing that enrichment, the processing, you're then able to provide a storage solution that can scale alongside that level of data coming in. We provide visualization out through the ArcGIS Enterprise. We can do live features as stream layers, or we can do live and historic features through the spatiotemporal big data store enhanced map and feature services that will allow for visualization of either discrete object or aggregated bins. So as you're capturing larger volumes of data, it provides some additional visualization options for that. And we also provide actuation, so we can, just as we can bring data in, we can also send data back out, be it notifications, alerting. It can actually be activating devices in an Internet of Things world where we're kind of responding to some sort of pattern that we've detected, and we're going to actually impact the environment by sending some messages out. At a high level, we're going to be touching on quite a few topics this morning. We're going to be kind of looking at some architecture recommendations, looking at some reasons and some methods around the big data storage solutions. We're going to talk about resiliency and scalability concerns and considerations, some looking at stream services, particularly why we'd want to use maybe stream services versus feature services. We're going to look at some service design considerations. So once you have everything in place, what are some kind of best practices about designing your analytics? And finally, just kind of a wrap up with a mix of kind of things I wish I knew, kind of a frequently asked questions, and kind of multiple topics we're going to discuss. But we'll start things off with some architecture recommendations. And now as you go online, you look at the product documentation help, you will see some minimum requirements. But what we have here is really kind of what we use typically when we're testing the product, when we're doing benchmarking of the technology. So if you ever see any kind of numbers listed about throughput and performance, this is based around this kind of class of machine. This is what we consider a commodity class machine. This is not the biggest server you could buy. This is, I think, standard within the industry for most production servers. We do recommend, whenever possible, to deploy GeoEvent Server in particular on either bare metal or kind of cloud instances, somewhere where it has a little more deterministic control over the resources. One of the challenges we hear a lot from customers that deploy this on virtual machines are that they get, even though it's the same amount of resources, they don't get the same performance out of it. And I think a lot of that is because you're sharing resources, which becomes a challenge. But also things like network, some of the different CPU usage, a lot of these things tend to be impacted as there becomes heavier volume on the networks. We do recommend, whenever possible, as fast as possible network speed. This particular class of machine that we have listed here, which is an M5 2X large, it is an 8-core 32 gigabyte machine that runs on Amazon. It has actually a network speed around 10 gigabytes a second, I believe, for network bandwidth. So, whenever possible, try to go for as fast of a network as possible. I know sometimes that's not an option when you're kind of working on an existing enterprise system. We do recommend 32 gig of RAM. This technology can be very memory intensive, particularly if you're doing a lot of geofencing or stateful operations that require a lot of information to be held in memory while it's being processed. But you also have kind of some pretty heavy CPU requirements as well, because we are ingesting high volumes of data and doing analytic and performance and modifications to the data while it's in transit. That can be very CPU intensive. But a big one I think sometimes people skip over, which is this last category here, which is disk space. While GeoEvent Server doesn't have a especially large installation footprint, it's only about maybe 700 megabytes for the installation. It uses at least with 10.6 and newer, it uses a file-based system for while it's doing the message logging. So while data's coming into GeoEvent Server, while it's doing the processing on it, that is stored at a file-based level for additional resiliency, but that does require additional disk space. On average, every input and every output you create within the GeoEvent Server can take up to 600 megabytes of memory. So while that doesn't sound like a lot, if you're an organization that's running 20 or 30 inputs or outputs, it can kind of very quickly creep up on you over time if you kind of forget about that. So it's important to kind of think of some of those considerations ahead of time. We also will be showing you a slide a few slides from now that kind of shows you how you can make some modifications about where those paths are located, particularly on Windows machines where you need to allocate additional disk space. Spatial-temporal big data store requires comparable requirements. We do again recommend, whenever possible, using machines that can kind of scale for this. Disk speed is very important for the spatial-temporal big data store, because we're writing high volumes of data out, and so we certainly want as fast as possible. Particularly if it's on a bare metal machine, we highly recommend using a solid-state drives whenever possible. Now, one thing we also want to touch on is the fact that when you are deploying the GeoEvent Server and the spatial-temporal big data store, these should be isolated from the rest of your ArcGIS Enterprise. It can be on the same network, obviously, but it shouldn't be on the same machine. The reason being, each of these components utilize a lot of the same resources, and you don't want them competing with each other and kind of impacting performance on one component or another. The spatial-temporal big data store does allow for kind of horizontal scaling, so you can deploy additional nodes of that, so for improved both performance and data resiliency by having those additional instances. And if you're using GeoAnalytics Server, so if you're in addition to doing some real-time analytics, you're also doing larger kind of batch analytics, you'd want to isolate the GeoAnalytics Server to run on a separate machine from the other components as well. If you choose to scale the spatial-temporal big data store for the additional resiliency, you also need to make sure you're running the same number of GeoAnalytics servers as well. GeoEvent Server can also be scaled up, although we do recommend that GeoEvent Server is run in isolated, kind of siloed deployments. And typically when you're working in a multi-machine scenario with GeoEvent Server, you have something like Kafka or some other message bus in front that can distribute messages across the multiple machines. Now, I mentioned just a moment ago about the disk space requirements for GeoEvent Server, particularly where the disk space comes into play in a component called the GeoEvent Gateway. This is that messaging system we're using on the back end for GeoEvent. For those running Linux, this is not something you need to worry about for the next few seconds, but on the Windows operating systems, when you're installing GeoEvent Server, you get to decide where you want to put it. I want to put it on my D drive, my E drive, whatever drives you might have on your network. But the gateway itself, the component that's used for the messaging, is always going to be deployed to your C drive. It's going to be deployed to the C program data Esri GeoEvent Gateway. So if you are an organization that uses very small C drives, where that's becoming a trend we've seen in a lot of organizations where they want to keep that main drive as small as possible, and you're going to be creating a lot of inputs and outputs over time, we do recommend that you modify these two configuration files, which are within the GeoEvent installation folder, and you can put a new pathway in for this gateway. So if you go, it'd be you open up these two files, Kafka.properties and Zookeeper properties, and just point it to a path where you'd like these directories to be created. And I do mean created. They will be built on the fly as soon as you modify this. I do also want to let you know that if you've already started using GeoEvent Server, you already have inputs and outputs and everything created, I do recommend you export that configuration first, because when you change these properties, it's going to create new copies of those folder structures. It's not going to migrate your existing configuration over at that point. Some other considerations regarding the installation side of it. GeoEvent Server and the gateway really should be left running. Treat them almost like a file system. I know that's sometimes hard because a lot of organizations have these practices where they like to maybe restart machines every Friday, or they think it's going to provide kind of better stability to kind of bounce these machines and get them back in a happy state. Unfortunately, programs like GeoEvent Server, they're always listening, they're always writing data out. By restarting them, you're effectively breaking what they're trying to do. If you do know that you're going to have to do some sort of restart, we do recommend kind of stopping the inputs and outputs before restarting, just so you're not trying to turn something off while it's actively writing out data. But it's also important to be kind of aware of some of the different dependencies. We are kind of a component of the ArcGIS Enterprise. We are using the same security model from Portal if you're federated, and so let's say you have your ArcGIS Enterprise on a different machine and you have to restart Portal. By restarting that, you will have to go back and then restart GeoEvent Server as well, because our security is all being controlled by that component. So if you turn off something upstream, just realize it's going to impact those other servers that are dependent of it. It can cause problems though, because we see sometimes where, again, if you haven't stopped your inputs or outputs, it's going to continue to try and write to data sources while they're off. So yeah, it's always a challenge. We do typically do a lot of updates to both the front end and back end of GeoEvent Server when we do patches or upgrades. So we do also require that you would clear your browser cache after doing any kind of patch or upgrade installations. Because we are doing those updates to the web application on the front end, you won't necessarily see those if you're not clearing your browser cache. So I want to talk a little bit now about some big data storage. As I mentioned just a few moments ago, you can scale out the spatiotemporal big data store across multiple nodes. You can scale it horizontally. This will provide a little bit better performance, but really what you're gaining is some additional data resiliency. And the way that's accomplished is, so you can of course use it with just a single instance of the spatiotemporal big data store, but it's recommended that you install that across multiple machines. And the reason we do that is the spatiotemporal big data store is able to control replication and sharding of your data. So what that means is when data's coming in, and you're set up with this kind of multi-node setup with the spatiotemporal big data store, the first event, the first data point that comes in is written to one machine, and a replica of that is going to be written to a second machine. Next point of data comes in, it's going to put that on a different server, and it's going to allocate yet another machine as its backup. And it's going to continue to do that, and it's going to handle the distribution and balancing of data across each of your nodes. So that gives you kind of protection of putting all of your data on a single machine because it's spread out across with backups. Now you can control that replication factor, so if you had more machines, you could have a replication factor of 2, where it would be, there's always going to be, my primary copy and then 2 copies somewhere else. But the point behind all of this is, let's say you have a machine failure. One of those nodes goes away. What's going to happen is it's going to automatically rebalance from those backup copies and turn those into the primary copies. It's going to say, oh, I also need a backup of this new data, and I'm going to move it somewhere else. So it's going to handle the rebalancing for you automatically. The other thing to keep in mind, and another benefit of the spatiotemporal big data store, is that typically when you're hooking this up to kind of real-time components, data can accumulate, sometimes very quickly, but at a minimum it's going to accumulate a lot over time. And one of the important things to consider is data retention controls. So you can set everything up and walk away, and then feel confident to say, I want to keep a month's worth of data, a year's worth of data, and it's going to automatically purge the expired or kind of old data for you without you having to go in and constantly kind of clean out some old data. If you have business needs to kind of keep the size of your data storage solution smaller. We also have control of how the data is indexed and also the types of object IDs that you're using, so you can determine, depending on what kind of client is going to be working with this data, what's the best way to scale and what's the best way to index that data while it's being stored. There's additional ways also to back up the data. So, beyond simply having additional physical copies of it, running actively, you can also do automatic backups. Now, these backups are snapshots of the data, so it's effectively kind of like zipping up exactly what's in there, the full folder structure, and exporting that so you could store that off-site. Or with the 10.7 release, we also allow you to do exports directly from the spatiotemporal big data store out as delimited text to either Azure Blob or Amazon S3. The benefit for this is that those cloud-based storages are really inexpensive, sometimes even cheaper than using local storage, and it also allows you to use that data in a format that maybe other data scientists in your organization could access it. If you had some other analytic tools you wanted to run, I wanted to send it through Power BI or something like that, you could utilize that. You could also bring it into GeoAnalytics or something if you needed to use it externally. I touched briefly on object IDs. The reason this is one of the things that most people don't even think about when they're thinking about object IDs. It's just one of the things that's always created for you when you're working in our desktop products. But by default, the object ID systems that are used by Pro, Desktop, Dashboard, most of our clients use an Int32 based object ID. What that means is it can store up to 2.14 billion records in that object ID before you basically run out of numbers. And that sounds like a lot, but at the rates that you'd potentially be bringing it into GeoEvent Server, you can run out of these pretty quickly. So if you're bringing in 100 events a second, you'll last most of the year, but you're going to get more than 3 billion records a year if you're bringing in 100 events a second. And if you're bringing in higher rates, let's say you're bringing in 10,000 events a second, you might last like 2 days before you've run out of potential object IDs. So what that means is you won't be able to open these data sources within any of, you won't be able to open them in Pro, Desktop, and a lot of the more traditional clients. What you would need to use then is either an Int32, an Int64, or a unique string for object IDs. So if you know you're going to be collecting at some of these rates that are shown here, you're going to need to look at using a different type of object ID. Unfortunately, if you do use these object IDs, you're going to be working with primarily JavaScript-based clients or something custom you've built. So you won't be able to open those data sources back up in Pro when you have more than 2 billion records within them. So we're going to kind of shift now and talk a little bit about some performance, kind of resiliency, scalability considerations, and for that I'm going to hand things over to RJ.
Thanks, Josh. One of the first things I want to note is that you should always have your patches up to date. If you haven't had a chance to, If you haven't had a chance to update to 10.7 or 10.7.1, we do have some issues that we have discovered that we have rolled back and backported into patches. So it is always good to keep the patch level up to date, making sure that you have the critical fixes that we've identified in the current release, plus any important fixes that we have managed to backport from a later release. And there are 2 patches for GeoEvent Server here that I'm showing. You want to go out to support and download those if you have not already applied them. I'd like to take a look at a GeoEvent service, for example, because for a long time we haven't done ourselves any favors talking about scaling GeoEvent in terms of the number of events that you're trying to ingest. And the story is actually larger than that. Here, for example, I have two inputs, and they're each providing 1,000 events per second. Of course, that means that the first filter that they're routing events to is receiving 2,000 events per second, so we know that that is the amount of message data that's going out on that internal message bus. Let's say all 2,000 of those pass that first filter, they're inside one of our security zones. That means that 2,000 events per second are being sent to each filter. Because of that branch, each filter needs to receive the full fidelity, the full set of event records to decide what it's going to allow through and what it's going to discard. If each of those filters cut the event flow in half, looking for just the trucks from input 1 and just the cell phones from input 2, that means our buffer, geotagger, and motion calculator are each getting 1,000 events, and outbound, we're getting 1,000 events on each of those nodes as well. So the point is really that you need to consider ingest, dissemination, and the event processing, the real-time analytics that you're doing all together. Because at some point, we've actually put 4,000 message records on that bus per second. And there's only the one message bus that's underlying all of your GeoEvent services. Josh mentioned earlier that a minimum of 16 gigabyte, probably recommended 32 gigabyte for GeoEvent server deployments. Out of the box, what I'm showing here is a ArcGIS GeoEvent config setting that limits the JVM to a maximum of 4 gigabytes. Now, one of the things that I personally would recommend is that you go into this file and set both the minimum and the maximum to the same value. I've had at least a couple of customers tell me that system stability is improved when they do not allow the JVM to dynamically scale. So I go into my system and I set both of these to 4 gigabytes every time I have to reinstall the software. And that's how I've set up our island downstairs in the expo. If you're going to be doing a lot of geofences, if you're going to be doing a lot of stateful operations such as enter, exit, incident detection, track gap detection, and you have a large number of trackable assets, you might need to increase these values to make better use of the RAM that you know that your machine is providing. As I mentioned, the trackable assets, there are some defaults that tend to center around 1,000 records. If you publish a map or a feature service, by default, it will only return up to 1,000 records when query. In GeoEvent, we assume that you're going to have about 1,000 unique assets. If you have 2,000 trucks, 3,000 trucks, you might need to come in and change this maximum cache size so that a track gap detector, for example, is able to keep track of all of the unique object IDs for the trackable assets that you're monitoring. Otherwise, if this is left at 1,000, the 1,001st asset that comes to the track gap detector will kick one of the other track IDs out, meaning that you're no longer monitoring gaps for that particular item. A particular setting for the incident detector, it's monitoring for incidents that match an opening condition or a closing condition. If I know that I'm going to have a high volume of incidents, I mean, incidents are usually exceptions to the rule. Not all of your vehicles are speeding at the same time. Not all of your vehicles are violating their spatial constraint by leaving the county or leaving their area of assigned operations. But in some cases, you will have large number of incidents depending on your opening and closing conditions. You might need to come in and set the maximum allowed open and the maximum allowed close incidents higher. Those are exposed through the global settings in GeoEvent Manager. I would caution against coming in and simply setting these values to very large numbers because you want to say, well, I'm going to kick all of these settings out to 10,000 just to make sure that regardless of how many vehicles are in my fleet, I know that I can handle what's going on. Particularly the first one will impact your system stability because every node, every filter or processor in every GeoEvent service that has to be cache aware, meaning it needs to remember something about the previous events that it has seen, is going to react to this value. and changing the maximum cache size in particular can come after your RAM in a very big way if you have a bunch of GeoEvent services. So I'd like to switch now and talk a little bit about stream services. I have a separate technical workshop that is focusing on feature services versus stream services. A second offering will be later today at 4 o'clock. So today, this morning, this is going to be a little bit of a lighter touch, but I at least want to mention kind of the difference between these two options. Stream services allow clients to subscribe to receive data. They're lighter weight, they can be more efficient, they don't require any sort of storage. Event records are ingest, they're processed, and they're passed out the stream service via a WebSocket for any clients that happen to be subscribing at the time. Because the event records are being pushed rather than retrieved via a periodic poll, it can reduce the visualization displays because the client is able to refresh its screen much faster and immediately when the data is received rather than periodically, and by default I think the web map can't refresh a feature layer faster than 0.1 minutes or every 6 seconds. That can make your data look a little jumpy, and stream layers are a little bit smoother in their display. There are some limitations with the web map and the JavaScript API on symbology and feature labeling. You can work around those using Pro 2.2. I have demonstrations of that I'll be showing in the other technical workshop. Feature services are kind of the opposite story. They do store the data. They require the server-side solution to persist the event records as feature records in an event in a geodatabase first so that that client can poll. There's some advantages there as well. If the server tries to write the feature record and fails for whatever reason, the service is not available, there's a network glitch, it'll get some sort of confirmation back and can retry. Stream services have no confirmation, they have no retry. They pass the record out, and if no one is listening at that instant, the record isn't received. I mentioned the unique symbology, and at least with the spatial temporal big data store, again, demos in our session at 4 o'clock, you have a lot of symbology control for on-the-fly aggregation for very large data sets and accumulations. You might want to consider using a map service and a feature service if you're using the spatial temporal big data store, because the symbology and the aggregation is not something that you can do with a stream layer. And then the data, of course, is persisted even when the client is not actively receiving the data, so you can do things like replay. Now you might ask, but can I have both? Can I have a stream service and also have some sort of data persistence? The answer is yes. There is a capability, store latest, that you can configure with a stream service. What I would caution is that stream services were developed specifically to decouple the concepts of data persistence from data visualization. And as soon as you turn on store latest, you're kind of breaking that design principle by bringing data persistence back into the picture, which means you might not be able to stream data as fast through the stream service as you want because you need to wait for the stream service to first persist the data in a relational database that can have a throttling effect of about 200 events per second. You can also store latest in the big data store, which kind of alleviates that problem, but then you're buying into the complication of having to configure and maintain the spatial temporal big data store, and maybe that's not what you want to do for your enterprise. You're trying to keep things lighter weight and only use the Postgres database that your portal's hosting server is using as its managed database. There are a couple of settings for stream services that I would like to highlight, and I'm going to go ahead and bring up the second slide that shows you the reduced values. By default, the maximum WebSocket text message size and the WebSocket buffer size are set to 1 megabyte. We've changed these values from release to release as we're trying to find that sweet spot for the majority of our customers and the data that they're using. An event record that has 2 or 3 attributes and a point geometry is pretty small. We're talking 60 bytes maybe, versus consider the polygon that is North America. Not only is it a fairly large polygon, but it has tens of thousands of vertices on all of its edges as it tries to model that jagged coastline. That's a very large event record, and if I try to bring a complex polygon such as that into GeoEvent for processing, it'll ingest and it'll process, but when it arrives at the stream service output, the WebSocket beneath the stream service can't buffer that data, can't format it as a text message, and the event record ends up getting dropped. If you have looked and analyzed your data and determined, I'm not using very complex records, my event records are all fairly small, you can get much better throughput if you come in and reduce these WebSocket text message size and buffer size from their default of 1 megabyte to maybe more reasonable values that I'm showing here of 65K and 32K. Some service design considerations. Josh was talking about architecture earlier. I'd like to take a look at some of the things that you can do inside the GeoEvent service. So a GeoEvent service we need to think of as a small program. You're not writing any code, but you are doing code-like operations. A filter might be a very, very simple operation, speed greater than 70. And how much time can that take anyway? I mean, to compare an integer versus another integer and make a decision. But there's still latency that comes with every one of these operations. The more complex your GeoEvent service that you configure, the more latency you're introducing between your input and your output. And what I like to remind people is that even if the collection of the nodes and filters and processors that you see here on the screen introduce only 1 millisecond of delay, there's only 1,000 milliseconds in a second. That means you're only going to be processing 1,000 events a second. And that is cumulative across all of your GeoEvent services. If you have several GeoEvent services that are introducing a total composite of 10 milliseconds delay, you're cutting your event throughput down to about 100 events a second. All GeoEvent services are using the same message bus, and they will suffer together depending on the complexity of your GeoEvent service. What I'm showing you here was taken from a customer that had a moderately complex service, and they had another simple service that was simply input field mapper output. And they found when they turned this complex service off, they were able to pass through about 2,000 events per second. When they turned this service on, it fell to about 7 events per second. Part of that was due to a bug that was introduced in 10.6 when we updated some third-party libraries. We hadn't tested with the complex service layout that you see here in all of the event routing paths, and there was a vulnerability that more complex services didn't play well with this particular version of a third-party library that we had updated. By the way, we fixed that in 10.7 and it's in the 10.6 patches, so again, you'll want to download those. But having had a few seconds to look at the service, how many processing event paths do you see? I see a total of 12. On the top side, coming through filter D, I have a split through that field calculator 3 to create 2 event processing paths. I have a similar split through field calculator 4 for 2 more, and another split through field calculator 5 for a total of 6. But I haven't accounted for the split upstream between filters B and C. 6 times 2 is 12. There's actually a lot of event processing paths that run through the service. So one of the questions I am asked often, should I be simplifying my GeoEvent services and maybe publish this as 6 separate GeoEvent services or even 12 different GeoEvent services? The answer in this case, 6 of one, half dozen of the other. When GeoEvent is operating as it's designed and not suffering from a vulnerability from some third-party library that we didn't understand, having a moderately complex service is no worse than having several straight pipe or simple services. You're using one message bus and you're not taking advantage. On the back end, we are using threading, but the threads are not allocated service by service such that a simple service will run faster than a more complex service. I would caution that having too many nodes in a GeoEvent service can simply become cumbersome inside the service designer as you're trying to keep your mind straight about the processors you're configuring, the filters you're configuring. I like trying to simplify my services as much as possible just inside Service Designer to make them easier to work with. But let's look at a different example. Not as complex a service, but is there a choice that I would rather do Service A or Service B? In this case, yes, there's a very clear winner. I would prefer to design this using the Service B and push the pre-filtering of the data as much as possible onto a component like a database that is much more efficient at using spatial views or non-spatial views, attribute selection, pulling data out, and have an input that is giving me red car, an input 2 green car, and an input 3 blue car, rather than a single input that is giving red, green, blue and sending it to 3 filters in parallel. Because again, each filter needs to receive all of the data so that it can figure out which events it wants to discard. I'm tripling the amount of data that I'm putting on the message bus when I have parallel filtering in this example. I like the analogy I use when explaining to customers, kind of like a pie. If I were to walk into a diner and order a slice of pie, and they gave me an entire pie, I ate a slice, and they threw the whole rest of the pie away, and then Josh came down and sat down next to me and ordered a slice of pie, and they gave a whole pie to him, he ate a slice and threw the pie away, no diner would ever stay in business. But GeoEvent is not a compiled language. There's no optimization that gets compiled into these GeoEvent services. They're very simple, straightforward. All the events have to go to every filter so that every filter can make its decision in an atomic fashion. If we look at some GeoEvent services and ask maybe which one is more complex, we also have to recognize that not all components are created equally. While Service B in this example has 3 processors, and we might think at first it's the more complex service, actually, because it is only using out-of-the-box processors, and some of those are taking advantage of cache, such as the field enricher going out to a feature service, pulling back in the data that it wants to use for enrichment, keeping it in memory. The geometric intersector is using the AOI manager and all the geofences that are in memory. The first service, even though it has 3 nodes, is actually more efficient and less costly, less expensive than some of the other services. Take, for example, the one that is now in the middle, Service C. Geometric operations such as simplification and projection can be expensive. And then the third option, a service area calculator, this is one of our custom processors that's available on the gallery. It's actually going out and using Network Analyst to do drive time analysis. It's pulling back results from a thick GP service. That can take several seconds. It could take many seconds. Now we're not talking millisecond latency, we're talking full second latency, and we're not going to be able to process nearly as many event records through a custom processor as you might through some of the out-of-the-box processors. A couple of closing points to consider before I hand control back over to Josh. I like configuring my filters and my field mapper processors as early as possible in my GeoEvent service. Yes, it is a best practice if I'm writing to a feature service that the last thing I do is field map to the feature services schema. That's still a best practice. But what I'm saying here is, from a programming perspective, I want to declare all my variables up front. If I know that I'm going to be doing field calculation, if I know I'm going to be doing field enrichment, if I know I'm going to be doing field geotagging, I want to have existing fields in which I can write those records into. Because that touches on the second point, I like avoiding managed GeoEvent definitions as much as possible. When I have a geotagger, for example, that creates a new GeoEvent definition in order to accommodate a new field that it is adding to a GeoEvent definition, and I then have a field mapper downstream, if I make any change at all to the GeoEvent service and click publish, That tears down the instance of all those nodes, and the geotagger, as part of its cleanup, will delete the GeoEvent definition that it created when it received the first record for processing. I now double-click my field mapper, open it up, and all of the field mapping configuration has been wiped off, and I have to go in and reconfigure all of the mappings field to field. If I can avoid having GeoEvent definitions created for me, then I avoid having those deleted out from under me, and I am less surprised with some of my event flow because I've already identified up front what all the schemas are that I'm going to be working with. Then the third point I've talked a little bit about, we want to use single data pipelines whenever possible. Try to simplify the service. Don't use a lot of branching and processing and multiple event flows in a service. Sometimes we can't help it, we have to do that. But if you can decouple and simplify the GeoEvent service and understand that it really is a small little program that's running, you'll build a system and a solution that operates in a more stable, predictable way, and you're going to get the event throughput that you're expecting with your solution. So with that, I'd like to turn control back over to Josh for our final section, Things I Wish I Knew.
Thank you, RJ. Can you click number 4, please? Great. So this last section is, it's going to touch on a lot of different topics. This is kind of the frequently asked questions that we get down in the booth, that we kind of always end up responding to customers at conferences about. So it's kind of touches on several topics. So one of the first things, and a very frequent question we get about, is federating GeoEvent. And the question people come up with is, well, I have to federate it, don't I? I don't have a choice. If you're going to be using the spatial temporal big data store in particular, it does require an enterprise type data store connection, but it doesn't require that GeoEvent server itself be federated. And what we're talking about by when I'm saying you're federating GeoEvent server, you're actually federating the local ArcGIS server that GeoEvent server is running on. Now, if you do choose to federate it, what you get is single sign-on experience. So basically, Portal is controlling all of your security. Your administrators within Portal will automatically then be administrators within that local server, and they'll be administrators to get into the GeoEvent server. Also, if you had installed GeoEvent Server and everything was kind of configured by itself running standalone, and it was using an ArcGIS server type connection, and then you federate it, it's going to automatically update your data stores to recognize the new security model. So it does kind of simplify that process for you when you do go back and forth, but you don't have to federate it. What you do have to do, though, I said again, if you're going to use the spatial temporal big data store, is make sure that you're using an ArcGIS Enterprise type data store connection. So I want to hold here for just a second. So with GeoEvent Server, there's really two places where you might be passing credentials. There's the, of course, sign-on, where you're first kind of logging into the application, and then there's the actual data store connections, where we're registering connections to the servers you're going to be reading and writing from. Those can be completely independent of each other. So the benefit of that is I could be an administrator on this machine. I can log into my local GeoEvent server, but I want to read and write data sources that are on a half dozen other environments. So I need to separate those that are kind of configured independently so that I can kind of talk to those different data sources. So then that usually leads us to the question of, why wouldn't I want to federate? Well, we do have some customers, particularly in those in kind of really more secure environments, ones that are dealing with kind of more advanced kind of certificate-based authentications that do play a little better when they're not federated. The other thing, again, while it can be an upside to have all of your Portal admins being admins on that local server, we do have some customers that might be in really large organizations where they don't want those Portal admins getting access to GeoEvent. So by keeping it kind of unfederated in its initial state, only those admins on the local ArcGIS server, only those local built-in admins would be able to access GeoEvent Manager and its services. So kind of following up on that, as I mentioned, having an ArcGIS server and an ArcGIS Enterprise type data store connection. But so what's the difference? What are these types of connections, and why would I use one versus the other? So there's three types. So we have ArcGIS Server, ArcGIS Enterprise, and ArcGIS Online. So we'll start with ArcGIS Online because that one's pretty straightforward. With ArcGIS Online, what you're doing is you're just going to be accessing your organization content of that user. We do support reading and writing from hosted layers on ArcGIS Online, but we don't support publishing new content. So what I mean by that is if you wanted to have a new feature layer that's running on ArcGIS Online, you're going to have to be publishing that either directly through ArcGIS Online or from one of our desktop clients, ArcMap or ArcGIS Pro. You're not publishing directly from within GeoEvent Server. ArcGIS Enterprise type connections are really a user level access. And by that what we mean is content that we do support reading, writing, and publishing, but all that content is limited to ownership of the credentials that you passed. So I publish an item to Portal, I own that item. I enter my credentials within GeoEvent Server as a data store connection, I will only see the content that I own. If RJ published some additional services to the local ArcGIS Enterprise system, and he might share them to me for Portal to look at and use in web maps, that doesn't mean I own them. I will not have access to read and write to those unless I have his credentials, because I don't own the content to work with it within GeoEvent. That's where you might want to use an ArcGIS Server type connection, where an ArcGIS Server type connection is a role level access. So if I'm an administrator, I can access that content that administrators have access to. If I'm a publisher, I have access to the content publishers have access to. Same with users. It's based on the role. So oftentimes what we'll see is organizations might make maybe a single headless account to work with reading and writing from services that multiple people in their organization might have created. Or they might choose to like that role base. We give users the option of controlling that access based on their needs. Another question we have is, users come to conferences, they see everything and they say, wow, I really like some of the new stuff you have in 10.7, but we're still on 10.4. Can I use GeoEvent 10.7 with my 10.4? And it's like, well, kind of. We do obviously recommend version parity. We do always recommend that you try and keep your environments up to date. But you can leverage some of the 10.7 deployments with older environments. Again, you wouldn't be federating this, but what it's going to really require is if you're going to be reading and writing from feature layers, that you're doing it over REST. So basically I'm polling an ArcGIS server for features, or I'm writing features over REST, just as if you would through a web browser. We're not going through some of the back-end mechanisms of writing directly to these data sources. Unfortunately, that means we're not going to support writing most of the operations through the spatiotemporal big data store, because that does require having that version parity with the data source and the way that it's storing the data. The other question we get a lot on that topic of kind of version parity is, RJ mentioned we have this, we had some custom components on this GeoEvent gallery. This is where we keep connectors to a number of different third-party provider feeds, components that can be maybe they're custom or sample components, processors. But a lot of times what users say, well, there's a 10.5 version of it up on the gallery, but I have 10.7. Or I have the 10.6 version, I'm getting ready to upgrade, and we really have to use this input connector. We can't upgrade until it's ready. And it's like, no, that's not the case. Most of the items that we have on the gallery are compatible with anything 10.4 or newer. There was some confusion of that with customers, so we've recently, within the last 2 months, we've gone back in and tried to update some of the documentation on that to basically show that, yes, it might say it's the 10.4 version of a component. That doesn't mean it only works on 10.4. That means it works on 10.4 or newer. So unfortunately, that wasn't very clear, I think, from some of the way they documented that. We will, of course, do new releases and updates to the gallery, but these are only when a component is not compatible. So let's say I've been using this, Twitter connector, and Twitter changes their API. Well, we're going to go create a new version of it. Or maybe GeoEvent at 10.8 uses some different backend system that's going to break what we built at 10.7. Then we'll release a new version of it. So in that case, when you would download these components, there might be multiple connectors inside the folder. If you're going to be doing, and we hope you're going to be doing, upgrades to newer releases over time, it is recommended that you would remove and then redeploy these custom components after upgrading. These things don't automatically get brought forward when you're upgrading the products. So if you do have a lot of custom stuff, you can go into the GeoEvent installation folder wherever you installed it. There's a folder called Deploy, which has all your custom components in there, and you can just literally, while the server's running, drag stuff out, do your installation, and then you can reinstall those components and be back in place again. If you're just getting started with GeoEvent, we do have a lot of resources online. We did a big push within the last 6 months to take a lot of the information that had been in tutorials and push that into the core help. Particularly on the inputs and outputs, there's a whole lot more resources now available for helping users with that. Also, we're very active on GeoNet. I think we've had more than a dozen new articles written in the last 3 months. They're kind of showing different use cases and different specific workflows that users have worked through on GeoEvent Server. And we also do kind of archive our previous recordings from technical sessions, both from our previous user conferences and also from our developer summit. So, please check out our video links as well. You can come back and look at some of our previous sessions you might not have been able to catch when you were here. So, as you see, we are on Thursday at this point. We have 2 more sessions left today. For those of you that are kind of interested in where we're going with this technology, where real-time and big data are going, we're going to be showing kind of the 10.8 story of GeoEvent Server, GeoAnalytics Server, and also a new product offering that's going to be coming to ArcGIS Online later this year. That is going to be at 2:30 this afternoon. And then as RJ mentioned, also our last session in real-time for this user conference on visualizing real-time data will be at 4 o'clock this afternoon. We also ask for those of you that are using the Events app, and we hope you are, it's a great tool. Please share your feedback with us. Every presenter is given this feedback directly, and it helps us ensure that the content we're sharing is something you're getting benefit from, and if we need to change anything for next year, it really helps us kind of narrow down what we need to be providing you. But with that, I will open it up to questions. Well, great. Well, no problem. Well, we will hang out here for a few minutes. If there are additional questions, I know it was a lot of content, but if there are specific questions, please feel free to come up and speak with us. Thanks, everyone.
Thank you.